Hello, this is Memphis Communiversity. We're going to be doing a polar free response question for practice for the AP Calculus exam. If you haven't seen our videos, what we do is we've created 10 videos for each free response question topic, including polar, parametric Taylor series, and the AB stuff like area and volumes, WQ, and so on. And for each free response question topic, we have those 10 videos, and we go from difficulty 1 all the way up through difficulty 10, slowly progressing in level, and so hopefully at the very end we will have mastered whatever free response question topic we're practicing. In this case, we're doing difficulty 8, so if you've seen our video series, we applaud you and we thank you for your support of our channel. But what I've been saying is that the first 5 videos have been pretty easy. They use the same questions, area, and then they have derivative questions. They use the fact that x is equal to r cosine theta, y equals r sine theta. Then the next 2 videos, difficulties 6 and 7, the prior 2 videos, those videos used the same rules, but it was non-calculator. So what we had to do is we had to take a lot of derivatives by hand and apply unit circle things by hand and things like that. But this is the first question, difficulty number 8, and I believe it'll be the same thing in 9 and 10, where there's just some sort of weird questions going on. They're not normal. So we'll see that this is not a normal polar free response question. We will be able to manage through it, but we need to sort of borrow some knowledge from outside of the polar realm and just other parts of calculus, as we'll see. So let's just get going. So we have these 2 regions. Of course, this is based off a former free response question, actually a quite recent one, but we sort of tweaked it to make it our own. So looks like we have this region S, we have this region R. We have these 2 angles, these 2 polar functions. Keep in mind that my graph isn't perfect, but this guy is going to be my circle, and this is the circle, even though it doesn't look like a semicircle. It's supposed to be a semicircle. And then this graph right here, the not cosine theta, this one is going to be this graph G. So if you want to label this as G, you can, and then this one is F. So we have 2 regions, so we're going to be doing some area questions perhaps. But first off, they asked me immediately a question that I'm not used to. The first question is about the distance between the points of a polar coordinate. I actually know that one. We've done that before, so let's do that before we answer the second part. So remember that the distance of a single polar curve between the curve and the origin is just the radius, because it's just how long you're going on that ray, that angle. So when you have 2 polar curves, the distance between the 2 curves is going to be the outer one minus the inner one. So for example, you have this ray, we can just draw this ray, and it's just going to be, the distance is from this radius, so the outer radius, meaning F, minus the inner radius, G. Keep in mind that this is how polar curves are defined. You have an angle, you have an R point, and then you have an angle. So you're like, okay, I'm going to take my angle and then go an R distance. Take my angle, go an R distance. So that's why it looks like this. It's not x comma y, for example. So in this case, d theta is not too bad. All it is, it's the outer one, which in this case is the semicircle, minus the inner one, being careful with parentheses, of course. So it's just 4 cosine of theta minus 2 plus 2 cosine of 2 theta times sine of theta. So this is what the distance formula is. We've done this before. The distance between the 2 polar curves is just the difference of the radii of the 2 polar curves, the outer one minus the inner one. So that wasn't too bad. Now we just have to do an average value question. So this is probably one of the first times I've ever seen an average value question in polar, but it's the same formula. So remember, we can write the average of any functions. Let's not use f because there's already an f, so let's just use h, for example. The average of h is 1 over b minus a, the integral of h from a to b. So the average over an interval, this is what the formula is. Keep in mind that this is not average rate of a change of h. Average value of h is different than average rate of change of h. Average rate of change is usually algebra slope, so it'd be h of b minus h of a over b minus a. So it's not, we're not finding the average rate of the distance, we're finding the average value of the distance. So all we have to do is, if we know this formula, we just have to apply it. So even though that they're using a formula that's not usually used in polar, if we just know the formula for average, then we can take that average. So in this case, what we're going to do is we're going to do 1 over pi over 2 minus 0. Keep in mind that this will be 2 over pi, because 1 over pi over 2 is 2 over pi. Then it will be integral from these 2 numbers, 0 to pi over 2. And then it will be just d theta. And then we'll just have to type this in a calculator, because this time we do get a use of a calculator, which is great. So we're going to go to this calculator. We're going to clear all this stuff, and then we're going to type this in. So keep in mind we're taking this integral. So math, go down to integral, and then it's going to be this function minus this function. Again, I'm going to be careful with parentheses. So we're going to go from 0 to pi over 2. Then we are going to go 4 cosine theta. So 4 cosine of x. I can use x. I can use any variable I want as my variable of integration as long as I'm consistent. And then keep in mind, I am being careful. It's 1 radius minus the outer radius. Technically, this negative would distribute, but if you just keep it in parentheses and you're careful, you don't have to actually simplify anything. So it's going to be 2 times, we're going to write times cosine of 2x times. Keep in mind that sometimes you have to put this times here because the calculator doesn't understand that it's a product. This calculator's name is Freddie, and he does help us out a lot, but sometimes he struggles a little bit where he likes certain things typed in a certain way. So this seems to be like what I want to type in. Maybe I need an extra parenthesis. Maybe I have too many parentheses now. Why do I have 4? So let's delete one. Then we're going to have x. And then we're going to see what this value is. And it looks like it's 0.858. But keep in mind that average is not just the integral. It is this number right here. Again, this is the same thing as 2 over pi. So we need to multiply our answer by 2 and then divide it by pi. So this is our final answer. It's going to be 0.546. So again, a pretty strange question. It's not a hard question. It's not a question that I think is too bad, especially because we have a calculator. All we're doing is setting up something, and the setup, again, is not too bad. All we did is we recognized that the distance formula is this because it's 1 radius minus the other radius, so r and r. And then what we did is we just subtracted. This was the distance, and we applied the average formula. The average of anything, the average value of anything is 1 over b minus a, the integral of that thing. So in this case, it's 1 over b minus a, pi over 2 minus 0, the integral of distance. And then we were able to solve this using a calculator. So now it's going to ask me another strange question. What we need to do is we need to find the angle such that d theta equals the average of d theta over the interval. So what we're going to do is we're going to take this guy right here, 4 cosine of theta minus, so this is d theta again, minus 2 plus 2 cosine of 2 theta times sine of theta. Hopefully type that in right. Let me make sure. Oh, we didn't type it in right. Sorry. I didn't see that this was not theta. This is just a single theta. So let me rechange these numbers. I apologize for that. This is just sine of x. So again, typing in the calculator is not a trivial thing. So we still need to multiply by 2 over pi. So 2 divided by pi. But yeah, just be careful when you're typing in a calculator. Don't mess up the pitfalls. In this case, the actual answer is 0.971. So my apologies for that. But again, typing in the calculator is something that my students and I often mess up. So just keep in mind this was a theta. So this was 2 theta. This was theta. So in this case, what we're going to do is we're not going to set this number to be this number. We're going to set it to the actual right number, which is 0.971. So we're going to set this to be 0.971 so that we can find a theta value. So let's try to do that. So what we're going to do is we are going to type these functions in using the graph. Let's clear everything out. Let's quit this. I'm going to take this number right here, and I can copy it. I don't think I know how, but we can just memorize it. 0.970892227. So it's going to be, we're going to use one of these as the function, 0.970. And then what was it? 89227. 89227. And then we are going to type in this function y. So again, what we're doing is we're setting up an equation. We want the distance, which is 1 radius minus the other radius, to be equal to the average of d, which will be this right here. So it's going to be 4 cosine of theta. Again, you got to be very careful with parentheses. People are more likely to maybe miss the parentheses than the actual math. So it's going to be 2 plus 2, and typing in the calculator, cosine of 2x. And then times, maybe we need to insert a 2 times here. So that'd be times. And then keep in mind, what I messed up the first time was I thought it was sine of 2x. It's just sine of x. So just sine of x here. So we're going to hit enter. now that we've typed in these functions. We can change the window. So notice I've already had my window set, but because we're only going from 0 to pi over 2, you can just make your window that so that when you graph it, it will already be perfectly zoomed in how you want to see it. So we're going to hit graph here. So this is my trig function right there. It looks like it's crossing and it's going however it goes. That's the distance formula, one radius minus the other radius. Now we have that point right here. So it looks like it does cross, but it might be a little bit hard to tell where it crosses. So let's just try to see if the calculator can figure it out. So 0, left bound, let's go way over here because I don't know exactly where the 0 is. Oh, sorry, we're not doing 0, we're doing intersection. Pretty struggling right now. So intersection, let's just go close to this area right here. Radius, second curve, right here maybe, guess maybe. And let the calculator do its work. Maybe we didn't give enough information, but it looks like we finally got a theta. Theta is going to be 0.517, 518 if you want to round. So again, what we did is we found our actual number for the average value, and we set it equal to this distance formula because that is what it's asking us. Is the distance eventually equal to the average? The average we found from the first answer. We graphed these two things and we found the intersection. It is theta equals 0.518. How do we tell if the function is going to be increasing or decreasing? All we need to do is we need to find the derivative of this number. So what we're going to do is we're going to take the derivative of this. So we're going to quit this. We're going to go to math. We're going to derivative. And then it's going to be x. We're going to type this function again for the last time, or maybe not the last time, but certainly for one more time. So 4 cosine of x minus 2 plus 2 times cosine of 2x times sine of just x. Let's be careful. We're going to plug in this number right here, 0.518, and we're just going to see the derivative. Why are we seeing the derivative? Well, it looks like it's negative. Almost wrote on Freddy there. 1.162. And how do you tell if anything is increasing or decreasing? Well, what you do is you take its derivative and see if it's positive or negative. So because this derivative is negative, that means our function d theta is decreasing. So let's take a little bit of a halftime break right now and review what we've done so far, because the next part will all be about areas. So in this case, remember that our first question was about distance. Distance we've talked about before in these videos. It's one radius minus the other radius. What we had to do though is we had to apply the average value formula on distance. Wasn't too bad because we have a calculator, but just keep in mind the average value is 1 over b minus a, the integral. What I would warn you about is what I messed up is keep in mind that sometimes when you're typing in the calculator, such a long function, you want to be careful of parentheses. We typed in 2 theta accidentally, but it's actually just theta on this side. So once you've set up the formula, typed it in a calculator, you are good to go. Then the second question said, use that number you just found, the average of the distance over this interval. Now set that equal to the function and tell me if is there an angle where the distance between the two functions is equal to the average of the distance of the two functions over that interval. So what we did is we found that number. It was going to be, that angle is 0.518. So basically at this radians, this distance is equal to this number right here, which is the average distance of all of these distances in the entire region. And then it asked a further question, which is finding the distance, whether it's increasing or decreasing at this value. So all we did was we took the derivative and we saw that it is decreasing because the derivative is negative. So again, this question actually didn't involve the normal questions, so that's why it's a little bit trickier. Difficulty number 8. It had x is equal, we did not use x is equal to r cosine theta. We did not use y is equal to r sine theta. We did not use dx d theta, dy d theta, dr d theta, or even dx dt, dy dt, or dr dt using the chain rule, or dy dx. Those are the things we're normally used to. In this case, we were used to doing distance between two polar curves. We've done that in the past, but we had to apply average to it. Then we had to use it as an equation, and then finally we had to take its derivative. So again, not your normal polar questions, but if you can stick to the guns that you know, both from polar and from the other parts of calculus, we should be fine. We know the distance formula, that's one minus the other. We also know averages, the average value formula, and we know that derivatives tell you if something is increasing or decreasing. So let's do a little bit of a review. Let's find the area of S. This one is not going to be too bad. So the area, remember, I think we've done an area question in every single polar free response question. Usually it's the first one. But remember that it's always 1/2, and then r. R is always whatever your radius is. In this case, we're finding the area of S. So notice the area of S is great because the boundary is always G. We don't care about F at all. So it's going to be this guy right here. So we're going to plug in R right here. So it's 2 plus 2 cosine of 2 theta times sine of theta. So this is the formula. This is the theta. It's 1/2 integral of r squared. But the only thing you have to know is the endpoints. In this case, the endpoints are actually pretty easy. Notice this point starts at 0 because when you plug in 0 here, you'll get sine of 0, which is 0. So that's 2. So that's why it starts over here, and then it'll graph to this when it hits pi over 2. Just to be sure, if you plug in pi over 2, well, when you plug in pi over 2, you are going to get cosine of pi, which is -1, times sine of pi over 2, which is 1. So you'll get -2 for all of this. So it'll be 2 minus 2, and that's why you're going to be at the origin, because you have radius 0. So in this case, the hard part about these area questions was actually pretty easy. It was just 0 and pi over 2. Not too bad at all. So again, this is just the area formula. Same thing as normal. Here, the area was actually pretty easy because the area was given to us. The intersection points were given to us, and always the intersection points are what are tricky in this integral. We did not square those, so let's be careful to square because it's always 1/2 r squared. And they do want us to type in a calculator, so it's not going to be too bad. So let's do that. So it's going to be math, not logic, but math, integral. Let's do 0 to pi over 2 because those are the intersection points. Those are the points that matter. 2 plus 2 times cosine of 2x sine of x. Let's insert a parenthesis though, because we do need to write r squared. So this is just the r part. So 2 cosine of 2x times sine of x. And then we're going to insert another parenthesis, and this will be squared, because remember the formula is r squared. And then we're going to type x in there. So we're going to get this number right here. And just remember that you do need to divide by 2. The area is 1/2 the integral of r squared. So we're going to divide by 2, and then that'll be our answer, 2.594. This is probably the easier question that has been on this question. On this entire video question, because the subpart, because the last two were a little bit weird. And this is just a standard area question where the intersection points were actually not too bad, the limits on the integral. So now we have a little bit weirder of a question, certainly. So what we're going to try to do is we are going to try to determine where we have this ray, so this angle, and what it's going to be doing is it's going to divide r into 2 equal parts. And what we want to do is write but do not evaluate an integral expression where the solution gives the value of k. So this is actually the equal area question that usually appears in area and volume free response questions. Check out our videos on those if you want practice for this. But let me remind you how that works usually, and we're going to apply the same concept to polar. So usually you have two functions like f and g. This is a different f and g from the front page, of course. So you have these two functions, f and g. You have an a and a b, like so. And then what you want to do is you want to split this region R into 2 equal parts. So notice that usually this region is not symmetrical, so it won't be midway. So there's going to be some region B, K. So for normal area questions, what it is it's the integral from A to this middle point, K, of top minus bottom, because that's how you find area in normal area questions. Again, check out our videos if you want practice with that. And then you just set this equal to the second half of the area, K to B, of f minus g dx. So this is the equal area question for normal area and volumes. So functions of f and g, not polar. Again, it's just one area equals the second area. Another way to think about it is you're finding the area to k, a to k, and you want that to be equal to the second half k to b. So the area of any function is the integral of that, the difference between the two functions from one number to a next. So again, we want this area from a to k to equal the area of k to b. This question appears quite often, especially on the AB exam. But of course, this is just polar, and polar is just on BC. So what it's doing is we're going to be applying the same thing. So we're going to be writing two integrals that are pretty similar. So it's just like in this one, we're going to probably stop at this middle point k. Okay, we can put the 1/2 because area has 1/2, but of course if you have this equation, the 1/2 would cancel. Then what we need to do is we need to determine the functions. But when you have polar, it is no longer f minus g, top minus bottom. It's going to be our normal r squared formula. But we have two functions here, so just keep in mind it's going to be the outer function, which is f of theta squared minus g of theta squared. So it's sort of like top minus bottom in those normal area questions, but in this case you're doing out minus n, and you're also squaring. So in this case it'll be f of theta squared minus g of theta squared. Hopefully you can tell what that is. We can stick a little d theta here. And keep in mind that the integrand is always the same in these integrals because you're going from one thing to the other. So in this case, what you're doing is say that this line happened to be where this area is equal to this area. I don't think that's the case, but just for illustrative purposes. So what you're doing is you're finding the area from one angle to the next. So for example, we're going from 0 to k, and then we're going to find the area from k to this number pi over 2. So that's why it's outer squared minus inner squared. And that's why it's going to be the same integral, the same integrand, because you're always, the outer squared minus the inner squared will be in the same in both regions. You want to find this area, so it's going to be opening up a book basically from the angles, and you'll find this region right here, and you want it to be equal when you open up the book to the rest of the thing. But notice that the integrand, same in this question as well, it's always the same on each side because you're finding the area of the same region. So in this case, this will be on this side as well of the equation. So it'll be f of theta squared minus g of theta squared. And then what are the endpoints? So all we have to do is come up with the endpoints. But again, this is just going to be 0 and pi over 2. It's the same thing as this. You're finding the area from 0 to k, and that's this formula right here, 1/2 r squared minus 1/2 r squared. And then we're finding the area of this, and we want to set it equal. So it's going to be the first half when we open up the book, and then we want the second half to be equal to that. So the first integral was the area from here to here, and then the second integral was the area from here and onwards. So again, not your standard free response question. Perhaps they'll never ask this sort of question again, and they'll stick to asking the equal area question and normal area and volumes. But we saw that it's still not too bad. We just applied our normal area and volume knowledge to this polar question. So it's 1/2 the integral of r squared minus r squared, because that's the first half of the area. Same integrand, so same 1/2, same thing right here, except we do have to change our endpoints because that's our area endpoints. We want the area from here to here to equal the area from here to here, but for both areas, it's still outer squared minus inner squared, where outer is always f, and then g is the inner. So hopefully you saw that while this free response question was a little bit trickier because it just asked things that are not normally asked, we were still able to do questions. We applied our knowledge of distance and average to find the average of distance. Same thing with knowing if a function is increasing or decreasing using its derivative. This question was the most standard question. It was just a normal area question. But then we applied our equal area formula when we had area and volumes to our polar question, and we saw that it was basically the same thing. The first half area is equal to the second half area. So that's why the integrand is always the same. You're just changing the numbers. You're going from 0 to the midway point where this ray actually does divide the area into 2. So basically this area is equal to this area. This was the first half, so we went from 0 to k, and then we went from k to the last angle, which is pi over 2. So hopefully that made sense. Hopefully you can sort of forgive me for typing in sine of 2 theta at the beginning. Certainly an honest mistake. Honest mistakes are not the worst thing in the world. Hopefully we can catch them, and even if we don't catch them, they usually help us improve. But if you want more improvement, we do have 2 more videos in this series. Remember that in my opinion, polar questions have been harder than even Taylor series questions. They have been maybe the hardest questions on the BC exam in recent years. So please check that out if you want more practice. Difficulty number 9 and difficulty number 10. I'm sure that they will be a challenge, just like this one was. So again, thanks for watching. I hope to see you during those videos, and we definitely appreciate your support of our channel. Hope to see you soon.